To build a hydrologic model of our site, we classified the soils using the NRCS method and performed in situ hydraulic conductivity tests. The soils were found to be a red sandy loam with low infiltration capacity. We're here on the patio today, and as you can see, the stormwater management techniques are suboptimal. Most of the ground is covered by impervious surfaces like this concrete, or is pervious but has slopes that are so steep that no water can infiltrate. Look at how steep this slope is. When rain falls on this slope, the resultant sheet flow erodes the ground and brings sediment into the storm drain system. Any water that falls on either of these two surfaces is conveyed immediately into storm drains like this and is then brought to a local creek. Our city currently has no stormwater treatment, so any water that falls in these storm drains and picks up any sediment or nutrients is conveyed directly to the creek without any treatment. Another aspect of our impervious footprint is our roof area. Any water that falls on any of these roofs is immediately conveyed into a series of roof drains, which is then channeled directly to the creek without any treatment. The goals of our project are threefold. First, to decrease the total runoff volume, peak discharge, and sediment and nutrient concentrations in the runoff using BMPs. Second, to create usable space in the patio for academic and recreational purposes. And third, to increase community awareness about sustainable stormwater techniques.
The current concrete sidewalks will be replaced with permeable pavers that will alleviate ponding during and after storm events. The pavers we have selected look like regular brick pavers, which complement the existing landscape design. We will remove the existing concrete patio space and replace it with a planted area with benches for seating. Perhaps our most innovative design feature is a terraced amphitheater that will replace the steep slope between the two wings of the engineering building. The terrace levels of the amphitheater will slow the flow of runoff down the slope and allow it to infiltrate on level ground. This amphitheater can be used by the community for seating and relaxation as well as outdoor classroom space on nice days. Our new design incorporates 3 rain gardens and a vegetated bioswale strategically placed for maximum interception of storm runoff. We plan to disconnect the roof pipes from the adjacent buildings so they drain into rain gardens 1 and 3. Rain garden number 2 is located at the top of the slope and will capture any sheet flow that is generated on the sidewalks and not infiltrated by the permeable pavement. Our redesign also features an elevated wooden deck with tables for studying and relaxing. This space will compensate for the reduction in the current concrete patio size, which is used as an informal gathering space for students and faculty moving between classes. These features will be on full display to the community and will be accessible for monitoring by student researchers. An informational sign will accompany each BMP feature to explain how each works and their impact on overall stormwater management at the site. Using the EPA Stormwater Management Model 5.0, we determined that our design features will reduce peak runoff from the site by 25%, reducing the load on infrastructure and local streams.
The project cost is reasonable, and we have identified at least 3 potential sources of funding at the university. We are excited to move forward with this project.